Hour. I miss you tons. This is problem number 16. This is my first video. Hopefully it'll be okay. All right, so I rewrote it. Here's some key things. The 20% is converted, and that you start off with a 1-liter container. Key. Because I know I have 0.1 moles going into 1 liter. I have 0.2 moles going into 1 liter. So then that tells me that my initial concentration of the H2 is 0.10 moles per 1 liter. Oh my gosh, 1 liter, that's so nice. The math is beautiful. And over here, my initial concentration is 0.20 moles per 1 liter. Oh my gosh, moles per liter, that's molarity, we know that. Okay, so now I know the initial concentrations, and what you're going to do, sometimes they call it rice. I learned that it was called an ice box. The first thing is you write the equation, and you want to write it big and kind of space it out so that you have room for everything underneath it. So I have H2 plus I2, and these are all gases. Remember, in equilibrium concentration, when we write those out, you ignore the solids, ignore pure liquids. So this is a gas, and this is a gas. Gives me 2HI, which is a gas. So step number 1 is the reaction. So sometimes they call this the R for a rice box. Okay, then I always make a box right underneath. Okay, I stands for initial. That's what you're starting off with. C stands for the change. And E stands for what it is at equilibrium. So initial, I have 0.10 molar of this. I have 0.20 molar of this. And initially I started off, I didn't have anything of that. C is the change. So right here it said that it used 20%. So I know that this is going to lose 20%. So 20% of this, so this is minus, I'm not going to use red, sorry. Let's use green. 20% of 0.1 is 0.02. So this loses 0.02. This loses 0.02. Now, remember how the coefficient here is 1, the coefficient here is 1, but the coefficient here is 2. If this loses 1, this loses 1, this has to gain twice that. So right here, this is going to gain 0.04. So my at equilibrium, 0.1 minus 0.02 gives me 0.08, 0.18, and 0.04. So now the very last step is to write that equilibrium constant. So K equals concentration of the products over the concentration of the reactant. So when some of you are doing this problem set, you were flipping this. So remember, products are after the arrow, reactants are before the arrow. Raised to the power of the coefficient. So my product is HI, and I want that equilibrium concentration. And since there's a 2 here, I'm going to square it. divided by the reactants. Well, there's no coefficients on those. So this is the concentration of H2 and the concentration of I2. Okay, I don't have to raise those to any powers of coefficient because there's no coefficients in this initial equation. So then I plug in my number. So I want my equilibrium concentration. So 0.04 squared divided by 0.08 times 0.18. Okay, so this, when I plug in the numbers, I get 0.11. All right, video number 1, problem number 16. Email me if you have questions.